So, good evening, afternoon, or morning, everyone, depending where you are. Welcome to day 7 of the Newcomers for Nuclear Summer School. Today, we turn our attention to one of the most critical dimensions of nuclear science: non-proliferation, safeguards, and export controls. These are the frameworks that ensure nuclear energy remains a force for peace, development, and global cooperation. As we explore these topics, we are reminded that nuclear knowledge comes with responsibility. It requires transparency, trust, and shared commitment to international security. We are honored to welcome speakers who are not only experts in policy and regulation, but also champions of a safer, more collaborative nuclear future. Let's listen, learn, and engage, because the future of nuclear governance depends on all of us. So for today's session, we have two brilliant speakers and role models of the nuclear industry: Dr. Jeremy Whitlock from Canada and Mrs. Eva Gianni, WiNI Global for Peace leader from Austria. So before we start, I would like to pass the microphone to Mrs. Eva, that she's part of this team and this program organization. We are so lucky to have her with us, supporting us hand by hand. Please, Mrs. Eva, over to you.
Thank you very much, dear Florencia. Good evening from Vienna, everybody. I am very pleased to be here today. I attended one session last week, but couldn't attend the other sessions because I was at the conference. And the one I did attend, it was really wonderful. I could also see all the very positive feedback that has gone into it. So it's really great. I would like to say a big thank you to Florencia and Lancina for organizing this summer school. I think it's very relevant for all of you. And I think you can benefit from it. It's free of charge. You just need to stick what you hear into your heads, and you can benefit immensely. So it's a great pleasure to welcome you today, and you will hear me talking more after Dr. Jeremy's presentation. Welcome to today's summer school.
Thank you, Mrs. Eva, for your remarkable words and inspiring way of carrying out and mentoring us. Thank you so much. So I would like to pass the word to Lancina to introduce our moderators for today's session. So please, Lancina, over to you. I hope you're having a stable network.
Okay, thank you, Florencia. Good evening, Mohamed, Ajwa, Dr. Jeremy, and our great support, Eva Vian. Thank you so much. Good evening. I hope you are very, very well and strong to be with us for this session. I'm going to present the different moderators. First is Mohamed El Sabah. Do you hear me?
Yes, we hear you.
Yes, we do.
Okay. Mohamed El Sabah is the Egypt-Japan University of Science and Technology, Secretary General of Egypt Young Generation in Nuclear. Good evening, Mohamed. You are a member of Egypt Young Generation. Thank you. Thank you. It's same. It will be great to have a young in our summer school, because young is the future. Next generation is the young. The future is the young. Mohamed El Sabah Hassan is a nuclear and radiation engineer specializing in nuclear system and safety. With both Bachelor of Science and Master Science degree from Alexandria University, he currently serves as a research design and manufacturing workshop manager at the Egypt-Japan University of Science and Technology, where he oversees engineering design, prototyping, and safety operation. He has over a decade of experience across academia, industry, and technological management, including role with Total Energy and leading engineering maintenance project in Egypt. Mohamed has training at Egypt Nuclear Research Center and Power Plant Authority, and represented Egypt internationally. One second, I have one second. Mohamed has studied in Egypt Nuclear Research Center and Power Plant Authority, and represent Egypt internationally at forums such as Forsage Rosatom Russia 2017. His career combined nuclear engineering expertise with a strong focus on innovation, safety, and youth engagement in the energy sector. Mohamed Al Jabbar Hassan, you have the floor. Thank you to be with us. Thank you so much. Hello, Mohamed.
Lansing, I think he had some issues to connect. So maybe can you introduce Dr. Jeremy to give the floor to his presentation?
Okay. Now I'm going to present Ajua Amonfi from Ghana. Ajua Amonfi is a nuclear science professional specializing in safeguard, non-proliferation, and international cooperation. She holds a MPhil in nuclear and radiochemistry and currently serves with the Ghana Atomic Energy Commission, where she focuses on nuclear security and safeguard implementation. Her career spans impactful role at the International Atomic Energy Agency (AEA) and the Nuclear Regulatory Authority of Ghana. Contributing to the regulatory review, compliance strategy, and stakeholder engagement, Ajwa is deeply committed to advancing the peaceful use of nuclear technology for a transparent, inclusive, and accountable framework. Her work champions capacity building and the mindful participation of youth and women in nuclear governance. As a moderator of the Newcomer4Nuclear Summer School, she brings a collaborative spirit and a global perspective, bridging technology expertise with advocacy to inspire the next generation of nuclear leaders. Thank you so much, Ajua, to be with us in this summer school. Hello, Florencia.
Yes. So for today's session, Joa will be our moderator for both. So please, Joa, over to you. If you can help us to introduce the brilliant speakers. Thank you.
Okay. Thank you so much for the nice introduction. So today our first speaker is Dr. Jeremy Whitlaw, and he'll be talking about non-proliferation and safeguards, enabling the nuclear revival. A little background about Dr. Whitlaw. Yes, Dr. Jeremy Whitlaw, as a private consultant, he's the founder and principal of Ottertail Consulting Incorporation. He has 30 years of experience in nuclear non-proliferation, reactor physics, and stakeholder engagement. He recently returned to Canada following 8 years at the International Atomic Energy Agency as a senior technical advisor and section head in the Department of Safeguards. His responsibilities included management of the safeguard concepts and approaches section and preparations for safeguarding advanced reactor and related fuel cycle technologies. That's specifically safeguards by design. Prior to this, Dr. Whitlock spent 22 years at Chalk River Laboratories in Canada as manager of the R&D program in non-proliferation and safeguards, and as a reactor physicist in CANDU and research reactor design. Dr. Whitlock received his BSc in physics from the University of Waterloo in 1988 and a Master of Engineering and PhD in reactor physics from McMaster University in 1995. So without much ado, I'll give the floor to Dr. Jeremy Whitlock.
Thank you, Joa. And thank you, Lancina, and thank you, Ava, for your words at the outset. And thank you to the organizers for the honor of talking today on this topic. And thank you on behalf of the global nuclear industry for putting on this workshop. This is the future of sustainable development in Africa and in the world. It's time for the nuclear revival to take the human race forward. And in order to take it forward sustainably and securely, we need to be talking about the non-proliferation aspects. So that's my topic today. I'm going to start by addressing why we need safeguards in the first place. What are safeguards and why do we need them? So we, of course, have this yin and yang of nuclear technology. You put nuclear fuel into the reactors, you get energy out. You also get irradiated fuel. You get the waste, and we have to deal with the waste. The waste contains not only leftover uranium, but it contains leftover plutonium. So you can make new fuel with the waste. You can reprocess it, or you can just treat it as waste and you can dispose of it. But regardless of what your intentions are with the irradiated fuel, it nevertheless remains true that it contains plutonium. And so this plutonium can be reused also in a nuclear weapon. And the nuclear weapons were, of course, what initiated the development of nuclear energy in the first place before it turned to peaceful applications. So we will always have this yin and yang, these two sides of nuclear technology. In order to benefit for humanity to benefit from from nuclear technology, we need to be able to have oversight then of of all of the fuel, all of the nuclear material, especially the irradiated fuel that contains plutonium, which is especially sensitive. And so there's two aspects of this. As you can see on the screen, there's in red, there's the diversion scenarios and there's the misuse scenarios. Diversion is where you simply move the fuel to a covert nuclear weapons program, and misuse is where you use the technology itself, the facility, to create more plutonium through irradiation of targets. And both of these are prevented by the application of safeguards by the IAEA. And this is not just a good idea, but it is a state obligation under the Non-Proliferation Treaty. The Non-Proliferation Treaty then is the way that nuclear technology is shared throughout the globe. And it's implemented through the International Atomic Energy Agency, the IAEA, which was established in 1957. And these are the benefits of nuclear technology. And these are also the goals of the IAEA to promote health and nutrition, food and agriculture, water and the environment, industrial applications, and these are largely through the use of radioisotopes. Then it also encourages and makes recommendations and sets standards in nuclear safety and security, and of course, encouraging nuclear power and other aspects of the fuel cycle. And all of this is enabled by a robust nuclear non-proliferation regime under the NPT. So if you will, all of these good things about nuclear, we don't want that to equal atomic weapons. And the connection is always going to be there, unfortunately, because it's a technological connection. So we have the IAEA with its many departments that promote the good benefits of nuclear energy on the left side of the screen. And then we have the Department of Safeguards, which makes sure that this technology can be shared without the ability to build nuclear weapons also being shared at the same time. So the NPT itself has three pillars. It's not just non-proliferation, but it does promote peaceful uses, those peaceful uses we just talked about. And there is a piece that also promotes disarmament, the drawing down of the number of nuclear weapons on the planet. The bargain that nuclear weapon states and non-nuclear weapon states enter into when they sign the NPT is that there will be this sharing of the beneficial uses of nuclear energy, without the spreading, the proliferation of nuclear weapons. Now, this is enabled by the Article 3 of the NPT, which is the safeguards requirement. So if you are a non-nuclear weapon state, for example, you sign the NPT, you must enter into a comprehensive safeguards agreement, which means that all source and special fissionable material in all peaceful nuclear activities is placed under international oversight. So this is what all nuclear material looks like and all peaceful activities in a nuclear program in the state. So going from the left to the right, you have perhaps mining, if you have mining in the country, which then turns the ore into yellow cake, conversion into fuel usable material. Possibly you enrich that fuel. If you're in Canada, you don't enrich the fuel, you just put it in the reactor. Then you have, after the reactor, you have the wet storage, which then goes to dry storage, possibly reprocessing. And at the end, you have the ultimate either reuse of the fuel or the waste from reprocessing, all the waste itself, if that's the choice, going into geological repositories. And so all of this is of Safeguard's interest, but we only place material accountancy, which is the oversight, the quantitative tracking of nuclear material around a portion of the fuel cycle. So we don't apply safeguards directly to the mines and the early part of the conversion process. And this is what you are entering into as an obligation under a comprehensive safeguards agreement. And then some things are outside of this. Then you have R&D that doesn't, at universities, for example, it doesn't involve nuclear material. You have component manufacturers that don't use nuclear material. You have waste that's called retained waste, which is kept aside. It's not on material accountancy books. You may have decommissioned facilities for which safeguards is terminated. And you may have irrecoverable waste farms. For example, the glaze on ceramic materials can be made with uranium, and this is not placed under safeguards. But all of it is of safeguards interest. And so one way we do keep track of everything, including the mines, including the yellow cake, is with an additional protocol that was developed in the last part of the last century to make sure that we have all of the activities in a state under oversight by the IAEA. Now, specifically, when the IAEA inspectors come to do in-field activities at a facility, you can see some pictures here of IAEA inspectors in practice. So applying seals, looking through devices that they can see if the fuel is actually spent fuel or if it's been replaced by dummy spent fuel, and then the real spent fuel has been diverted. And all of this speaks to nuclear material accountancy. And this is the tracking of nuclear material inventory and flow done by the facility itself. It does this for nuclear security purposes. It does this for safe operation. It does this for economic operation. The operators need to know where their nuclear material is at all times. And they also report a portion of this to the IAEA through the regulator, through the national regulator, and the IAEA comes and verifies through the processes you see on the screen in the photos. In between the inspections, you have to know that you have continuity of knowledge, and you do this by verifying the containment or the rooms or the containers where the nuclear material is located, and you have surveillance such as cameras to observe and know that the material has not moved since you last verified it. None of that matters if the facility has not been built the way it was supposed to, if there is a secret room somewhere or secret equipment. And so you need to verify the design. That's very important. And in addition, you can take samples, environmental samples, and under that additional protocol I mentioned, you can actually go anywhere, the IAEA can go anywhere it feels it needs to in a state to answer questions about the nuclear activities in that state. So these are the tools available to the IAEA, providing information that allows it to draw conclusions. And that's the first pillar you see here in this slide. It safeguards relevant information. So where does the IAEA get its information from? The first pillar we just talked about, IAEA verification activities, including its inspections, its design information verification, very important, and these complementary access visits where it can go anywhere in the state. So that's what the IAEA does. The central pillar here is the information that the state provides. It provides the nuclear material accountancy. It provides the design information. It also can do voluntary reporting of some other isotopes. And there is this additional protocol. So this is a collaborative effort between the IAEA and the state to ensure that the nuclear activities are sustainably developed and implemented in the state. And then there's other relevant information on the right, which is open source information and third-party information. So the IAEA does receive information from other countries or other agencies, which it then analyzes, verifies, and then acts on if necessary. A very quick look here at the overview of the safeguards implementation last year in 2024. A lot of numbers here. So I leave this for your later reading, but I want to point out to you a couple of numbers. One is that these safeguards are in place in 191 states. mostly comprehensive safeguards agreements. Some of these are nuclear weapon states as well, and some of these are a third type of application. But in general, 191 countries on the planet. So that's most of the countries on the planet subscribe to the Non-Proliferation Treaty and are under some form of safeguards. The other interesting number is this one, 240,530 significant quantities of nuclear material on the planet are under safeguards. Roughly speaking, significant quantities can be thought of as critical masses. So this is like over 200,000 atomic weapons worth of uranium and plutonium. A lot of that is spent fuel, so it's the irradiated fuel, is under safeguards. Now that's not all of the nuclear material on the planet, of course. That's about half. And the other half is sitting in nuclear weapons countries and is not under safeguards. So about half the nuclear material is in countries that are non-nuclear weapons countries and therefore under full scope safeguards. Now, that said, we've been doing safeguards since the 1950s and 1960s, and now we bring ourselves to 2025 and looking forward, what's the new priority? Well, currently, looking forward, it's the SMRs. With SMRs, we see advanced technologies, locations, modes of operation, fuel designs, new countries taking up not nuclear weapons, taking up nuclear energy to advance development. And for all of these reasons, whether it's the development of the technology, which is new, or the development in the country, which is new to nuclear, we need to have a sharing of information and a development of a sustainable safeguards regime. Also, currently, we are dealing with a lot of waste from legacy applications, legacy research, from nuclear reprocessing. So there's lots of waste, lots of spent fuel, which is sitting in storage, above ground storage, or in spent fuel pools, and maybe going to dry storage or going to a geological repository. And maybe it's just cleaning up of old facilities and generating waste. And you see a barrel here on the right with waste that's been compacted into a barrel. We don't cut them open like that, but that's just one for display. Anyway, that's all under safeguards as well. And there's a large volume of nuclear material there that needs to be under seal and camera and other forms of safeguards. And there's new processes involved. And so this is a big area that the IAEA is involved with in developing new safeguards approaches and raising awareness in the member states that these processes are actually under safeguards in the first place. So in order to aid with member state understanding, we have the IAEA has lots of guidance programs available. There's the ISAS missions, which provides, it's an advisory service that the IAEA provides to assess the quality of the SSAC, which is the state system for applying safeguards for accountancy and control. You can think of that as the regulator or the state authority. So assessing and advising. There's also a more detailed involvement called a program called Compass, where you can more directly build the capacity in the regulator, in the state authority, in these newcomer countries. And then we have integration of safeguards into other advisory missions, such as the milestones application for developing a nuclear program. You have to also develop the capacity for safeguards and technical safety review recently at the IAEA. So just looking at current operations and how well are safeguards integrated into the operation of these facilities. There's the traineeship program where member state representatives can go to spend some time in Vienna and learning all the details of safeguards, and also a large number of national, regional, international, in-person and online training courses. And there's third-party training opportunities as well being offered, like the one that I'm speaking at right now, of course. So in summary, so nuclear technology, as I'm sure we all agree, nuclear technology drives sustainable development. It's a key part of it going forward, but nuclear technology itself needs to be developed sustainably. The global non-proliferation regime has enabled sustainable growth of nuclear energy for over 70 years. And international safeguards are the cornerstone of that non-proliferation regime, represented by my little cartoon on the right here, which shows you the nuclear material, surrounded by the nuclear material control and accountancy, which is the brown part with the lock on it that says operator. So that's the facility. And then the agency comes along with its cameras and its own seals, which it puts on the same containment, perhaps, and verifies. So it's again a collaborative effort. It's also applies to security as well. But the difference with security is that the verification is done by the international agencies, not just advice. It's actually the legal mandate to verify. So preparing for this nuclear revival, which we're happy to see upon us, requires then both the IAEA and state readiness and collaboration. And for this, guidance is available for member states. With that, I'm happy to take any questions. Thank you.
Thank you very much, Dr. Whitlock, for the amazing presentation. So we are going to take the question and answers at this point. If you have any question, you can either leave it in the Q&A session, or you can raise your hand and then you can ask your question live. So there is currently one question. I'll read it out. Hello, Dr. Jeremy. I'm from Morocco. Thank you for the presentation. My question is, why is uranium dioxide often used in the form of pellets as nuclear fuel spent? So
why is uranium dioxide used for fuel? Well, for a very simple reason.
In the form of pellet for nuclear fuel.
Why is it used, or why is it used in pellets? I'm not sure which.
Says, why is uranium dioxide often used in the form of pellets?
Okay, it's used in pellets because that's an easy way to assemble fuel. That you can take the individual pellets and put them in by the hundreds into the fuel elements, one by one. So it's for ease of manufacturing, and also allows space between the pellets. Then, if the pellets are sort of 1.5 centimeters in length, you have space between the pellets for fission gases to build up as well. So it's for manufacturing as well as volume of allowing fission gas pressure to build up. And you use uranium dioxide in the first place rather than uranium metal in a power reactor, because you need to run the fuel at over 2000 degrees. You need to run it at very hot temperatures to get the efficiencies, the thermodynamic efficiencies. So you can run a research reactor with metallic fuel because you're not generating power in that case, just neutrons. And so you won't exceed the melting temperature of the metal in that case. A power reactor will exceed the melting temperature of metallic fuel in general. And that's why you go to a ceramic fuel that can sustain higher temperatures. Great question.
Okay. Thank you very much for the answer. There is another question that says, what is the level of participation on newcomers to nuclear in the safeguard program? I don't know if you get this. Okay, I think someone is answering that. So there's a lifted hand. I'll allow to talk so that they can ask their question.
Yes. So the participation of newcomers is there's high participation of newcomers. The IAEA reaches out to the newcomer countries, and also newcomer countries take part in many of the opportunities, the training opportunities, and the missions. So the missions that I listed, the advisory missions, taking part in the milestones approach, which is a structured approach to developing all the necessary aspects of a nuclear program.
Okay.
Oh, I see now. Joa would like to answer.
No.
Oh.
I put it down so the between us. Okay.
Okay.
I think the time for our Q&A is up, and there is no more question. But if anyone else has another question to ask Dr. Whitlock, you can still leave it in the Q&A session, and then we will take it after Ms. Eva's presentation.
Okay, thank you very much.
Thank you so much, Dr. Whitlock. Okay, so I'll move on to introduce the next speaker. Our next speaker is Ms. Eva Jan. She'll be presenting on nuclear export controls. the why. And a little background to Miss Eva. She is the WiN Global Technical Leader and WiN for Peace Leader. She is a senior nuclear professional with more than 40 years experience in the nuclear field at the international and national levels. She has worked with the IAEA as a nuclear safeguards inspector and in other positions in the Department of Safeguards, as well as the United Arab Emirates Federal Authority for Nuclear Regulation as a senior nuclear expert control specialist. At the IAEA, she was the senior inspector for implementation coordination in the Iran task force, overseeing the work of inspection teams during preparations for the implementation of the Joint Comprehensive Plan of Action, the JCPOA. Ms. Eva is actively involved in Women in Nuclear Global, where she holds the position of the technical leader and leads the group WiN for Peace. She was the president of WiN IAEA from 2009 to 2016. And she holds an MBA from the Economic University of Vienna, a BSc honors in physics and chemistry from the Open University, and a Master of Science honors in nuclear science and technology from Manchester University. Ms. Eva, the floor is yours.
Thank you very much, dear Adjoa, for your kind introduction. So I'm one of those safeguards inspectors. I used to be, and in case any one of you is interested in that job, it's the coolest job on this planet, but that's a whole going to tell you today. So I'm going to speak about nuclear export controls. You may say, what is that and why do I need that? Well, you should know that you can't just buy certain nuclear-related items at Walmart or at Amazon. They are strictly controlled, and the nuclear exporters have certain requirements for those who want to import certain equipment and technology, and that is what I'm going to speak about today. So actually, nuclear export controls are based on the Nuclear Non-Proliferation Treaty, Article 3.2, which says that transfers to non-nuclear weapon states of source or special fissionable material and equipment or material especially designed or prepared for processing, use, etc. of special nuclear material can only occur if it is subject to IAEA safeguards. Nobody quite knew what is this especially designed or prepared when the NPT was drafted. So the Zanger Committee was founded to define what is especially designed and prepared, and they developed a so-called trigger list in 1974, which is published by the IAEA as INFCIRC 209, which you can check up on the IAEA website in case you're interested, and which has been updated several times since then. Then the Nuclear Suppliers Group was founded, and they also developed the trigger list in 1978, which again is published by the IAEA as INFCIRC 254 Part 1. And they also developed a so-called dual use list, which is published as Part 2 of INFCIRC 254. Another important event was UN Security Council Resolution 1540. That was following the events of 9/11 in the US and the discovery of a clandestine nuclear network, which addresses the threat by so-called non-state actors. So not at the state level, but at below the state level. So it can be terrorists or whoever. And one of the requirements of UN Security Council Resolution 1540 is for states to establish appropriate domestic controls of nuclear, chemical, and biological to prevent the proliferation of such weapons. Let's have a closer look at the Nuclear Suppliers Group. So this is a group of the major suppliers in the world. It's about 48 countries currently, and their aim is to prevent nuclear proliferation through the implementation of export controls on nuclear and nuclear dual-use items, equipment, and technology. They established those guidelines that I mentioned before, and they promote the responsible nuclear trade to NPT, non-nuclear weapon states, and they keep those lists updated from time to time. The importance of this group is that it prevents the spread of nuclear weapons technology, and it tries to strike a balance between the non-proliferation goals with the peaceful uses of nuclear energy. So those guidelines must not be too strict to inhibit the legitimate trade, but they should not be too loose to allow proliferation. Some of the challenges are that the NSG is often viewed as a political tool in favor of certain countries. And also there has been an ongoing debate about the membership of some countries, like, for example, India, which was actually the reason why the NSG was established in the first place. There are some in the guidelines of the NSG, if you look at part 1, those are the so-called nuclear-related items, which can only be used in the nuclear field. Those EDP, especially designed and prepared. The guidelines require that there is a prohibition of nuclear explosives, and this has to be done at the government level. So the government that receives those items needs to provide assurances to the exporter that the items will only be used for peaceful uses and will not result in any explosive nuclear device. As mentioned before, this also requires the establishment of a comprehensive safeguards agreement with the IAEA. So only those states will receive the items which have such a CSA in force. There's the non-proliferation principle, which means that suppliers should only transfer items if the transfers do not contribute towards the proliferation of nuclear weapons or to acts of nuclear terrorism. Then there has to be the observance of the provisions of INFCIRC 225 related to physical security at the facilities and during the transport. There's also a control on retransfers. So the recipient of the retransfers need to provide the same assurances like the original transfer. And there are special controls on sensitive exports. So this is basically enrichment and reprocessing facilities, equipment, and technology, because these two technologies could directly be used to produce material for nuclear weapons. Cannot see the top. Sorry, let me go back. So let's look at some examples of what are trigger list items. So that's, for example, a source and special fissionable material. That is any isotopes of uranium, thorium, and plutonium. Then, of course, we have nuclear reactors, and this can be either complete reactors or parts thereof. Then also non-nuclear material for reactors, which are used as moderators, for example, deuterium, heavy water, nuclear-grade graphite, reprocessing plants and equipment, fuel fabrication plants, enrichment plants and equipment. For dual-use items, there are also some provisions. So there's, again, the non-proliferation principle. This will only be used for peaceful activities, and it will not go to unsafeguarded nuclear fuel cycle activities. There's also an end-user control. It means the exporter requires an end-user statement that specifies the uses and the end-use location. There also has to be licensing in place in the recipient country. So there have to be export licensing regulations, enforcement measures, and in case there are any violations, there have to be penalties that can be implemented. And the exporter has a consent right over retransfers. So for transfers to non-NSG states, the supplier should obtain assurances for retransfers. Let's look at some examples of part 2 dual-use items. So this is the categories are equipment, assemblies, and components. For example, high-density radiation shielding windows, which, as you know, may be used for hot cells, for shielding. It's the same with remote manipulators. Then we have test and production equipment. This can be flow forming machines, which can be used for producing rotors for uranium enrichment. Certain machine tools, induction furnaces, isostatic presses. Certain materials are also controlled in part 2, like, for example, aluminum, beryllium, bismuth, boron, and several others. And very important, the guidelines also control software and technology. So for software, that is especially designed for the development and production or use of the equipment, and the same for technologies. So these are the so-called intangible transfers, which are not physical transfers, but usually in digital form. So you may ask yourself, why do we need export controls? First of all, we need to comply with the treaty, the NPT, and with UN Security Council Resolution 1540, which are the preconditions for the supply of any listed items. Another objective is to prevent the development of nuclear weapons by preventing the unauthorized access to nuclear weapons technology and materials, and also the diversion of nuclear material and equipment, which enhances global security because it means that it maintains the peaceful nature of nuclear trade and also supports the global confidence in the peaceful uses of nuclear energy. And we have heard about terrorism prevention. Nuclear export controls also mitigate the risk of nuclear terrorism and illicit trade networks. How are nuclear export controls implemented? So I've mentioned the export licensing requirement. The national nuclear regulators need to have comprehensive licensing systems in place for nuclear exports and imports. So the exporters for exports, obviously, and the importers also for imports, they need to know what comes into the country and be aware where those items are at any time. There's also information sharing by the supplier states, so they cooperate and regularly share information, also intelligence information. The IAEA does some verification and monitoring, in particular on the nuclear material. That's uranium, thorium, and plutonium, as I've said, and also on some equipment, specifically under the additional protocol that Jeremy has mentioned for the imports. The IAEA has the right to monitor imports to certain countries adhering to the additional protocol. And I've mentioned the legal framework, so you need a robust legal framework with penalties for violations. Let's now look at the 3S principle, of which you may have heard before. So the 3 S's stand for safety, security, and safeguards, plus nuclear export control requirements. And these 3 S need to be integrated into, or should be integrated into, all nuclear activities. So the major nuclear suppliers need to implement the NSG guidelines for nuclear transfers. And there are no nuclear transfers without national nuclear export controls. So if your country wants to import nuclear technology, they need to be aware of nuclear export controls and have all these provisions in place before. Because from my own experience, I know that if you want to import a reactor and you don't have the regulations in place and the licensing in place, this will lead to delays in receiving those items if you need to set that up first. Let's now look at how this works in practice. Let's say a country already has a reactor and wants to import nuclear fuel. So first of all, I've mentioned nuclear export controls. Before you can even import the fuel, you have to have a CSA in force, and your government needs to assure the exporter that the fuel will be only used for peaceful purposes, the so-called government-to-government assurance. There's also nuclear security in place during the transport and the physical protection during storage and use. So nuclear security is always very important. Then, of course, we have nuclear safety. The nuclear reactor, it has been built in a safe manner and has all these safety features in place so that both the fuel is both safely stored and safely used in the reactor. And of course, we have nuclear safeguards, which at any time accounts where the fuel is and what it is used for and where it is located, and that ensures that it is used as declared for peaceful purposes only, and which is then monitored both by the state authority and by the IAEA. So this brings me to the end of my presentation. And in case you need more information, here are my details, how you can contact me. Thank you. If you have any questions, please go ahead.
Okay, thank you very much, Ms. Eva, for your wonderful presentation. We have one question from Florencia. She says, thank you for a great presentation and your answer. How about the regulation for imports and exports of software that are related to nuclear energy? Is there regulation for import and export of software that's the non-material nuclear related tools? And how can the IAEA support that?
Okay, thank you for this question. Let me start from the back. Actually, the IAEA does not conduct nuclear export controls. It's the matter of the countries, of the exporter and the importer. I have already mentioned that not only items, physical items are subject to nuclear export controls, but also so-called intangible nuclear technology. Intangible means you cannot touch it. That means that's software and technology. And that is also subject to nuclear export controls. It's also listed in the NSG lists. Of course, this is more difficult than with physical items because with physical items, they have to cross a physical border, and then there's the customs authorities that will check the items and etc. So it's easier for physical items and it's more of a challenge for intangible technology. But of course, it's also subject, because just imagine if some of this sensitive technology were spread all over the world, that would not be a good thing. And actually that happened in the case of uranium enrichment technology, which was proliferated by a Pakistani scientist called Abdul Khadir Khan, which is why Iran, North Korea, and Libya have or had nuclear enrichment technology. Okay, I can see another raised hand.
Maybe if the participant can raise a hand again, just to allow him or her to talk. Sorry, that
Okay.
question was not coming from me. I mean, I think it was from a participant, but they keep using my registration link.
Okay.
And
I think there's another raised hand, so I'll allow that person to talk. Lawan Mohammedu.
let me identify Mohammed. Mohammed, maybe can you raise your hand one more time? Oh,
Okay.
great.
So I think the next person can talk if Mohammed is not ready.
Yes, I give permission to Mohammed, and also we have a question from Fatima, and from Fatima we have it there.
Yes, okay. So the question from Fatima says, thank you for your presentation. Please, can we get to the Can we get the presenter's slide? And then the next question is, what does one need to be in nuclear security? And then also, can a nuclear security or RSO oversees the entire process of transporting nuclear or radioactive technology?
Okay, thank you for the question. So nuclear security has developed as a discipline of its own since the early 2000s. Like, for example, at the IAEA, there was no nuclear security in place except the physical security. But after 9/11, this changed dramatically, and it was realized that nuclear security measures need to be in place in order to also be ready for the case of non-state actors like terrorists, etc. So nuclear security does not only ensure the secure transportation of nuclear material and nuclear items, but also the use at the facilities. So there are nuclear security measures in place, and many other things. Also, cybersecurity falls under this. And I suggest that if you are interested in nuclear security, please check out the World Institute of Nuclear Security, WINS. They offer online courses, free online courses, which you can take at your own pace and also obtain some certificates if you complete the course. So I refer you strongly to WINS. It's actually based in Vienna, like myself, and they have very good courses. So please, if you are interested in nuclear security, it's actually a domain that requires more resources than it has now. And I could imagine that if you're from a country that wants to introduce nuclear power, it would be great if your country also has some nuclear security professionals. And they are very short on women. So any women here who are interested in nuclear security, please check out WINS. And if you have any more questions, let me know. Oh, thanks for the website, Florencia.
Okay.
You have it in the chat. You can see the website.
The next question is, can a nuclear security or RSO oversee the entire process of transporting nuclear or radioactive technology?
Sorry, was that the question? What does one need? Can a nuclear security or RSO oversees the entire process of transporting? Yes, of course. There has to be an oversight, and there are standards in place and guidelines by the IAEA for the transport of nuclear and radioactive material. I also encourage you to check out the IAEA website. They have a lot of information which you can study by yourselves. For example, if you're interested in nuclear security, go to the Department of Nuclear Security. Safeguards the same. Also open an account in Nucleus, which is the IAEA's online training program. You have a lot of courses there which you can take, which explains all these concepts to you.
Okay. The next question is, how can experts ensure that dual-use items are not diverted to undeclared nuclear activity?
Well, as I mentioned, one of the measures is to provide an end-user declaration, and then also to have the right to check whether the declared end user is indeed using those items as declared. The actual monitoring is not as straightforward. It depends on certain arrangements, but I think countries are working to be able to control the end user. Of course, in the case of dual-use items, it is really difficult to strike this balance between what is legitimate and what is not legitimate. The dual-use list was created after the experience in Iraq, where the IAEA found in the early 1990s that Iraq had a clandestine nuclear weapons program, And a lot of the items they had installed were dual use, completely dual use, like the isostatic presses, for example, which are used in industrial applications, but which are also used to compress the nuclear core from all sides in a very, very, very precise way. So it is not easy, and actually the IAEA has an information analysis system in place, as Jeremy has mentioned, which looks at different sources of information to determine whether there are any indications of undeclared nuclear activities, which is done through open sources, through the study of scientific literature, and many other things. So it's not 100% sure, but of course, everybody's trying their best.
Okay. And the next question is, what is the procedure in the case someone exports something, example, scrap metal, but unintentionally found nuclear or radioactive material? It applies the same as you mentioned, or some, does it apply the same as you mentioned, or it's something different?
That's a very important question. It only shows that if you have scrap metal and there was some nuclear radioactive material present, there was no oversight of that nuclear or radioactive material by the regulator. And this has led to accidents in the past, like in Brazil, for example, where a whole huge area was contaminated because some kids found some shining metal, which was radioactive, in some scrap metal, and brought it home, and several people died from it. So this is why it is really important that the regulator at any time knows what radioactive material comes into the country and where it is located. And of course, in the case of nuclear material, you have the control of the IAEA in addition to that. But it's really important. And in case you inadvertently find some radioactive material, I mean, I don't know what are your jobs and what you do every day, but suppose you have some radiation detection equipment and you do find some indication that material is radioactive, you should report it to your regulators so that they can take appropriate actions. Yeah.
Okay.
Would be my answer.
There is another question that says, how can IAEA guarantee that all information related to a particular country's nuclear program is not shared by IAEA inspectors with other countries?
Wow, that's a very tough question. So I was an IAEA safeguards inspector, and it would never have occurred to me to share any of the information with anybody. Actually, you have to sign a confidentiality agreement when you become an IAEA inspector. And I know there have been a lot of rumors that inspectors have shared information with in a way that they were not supposed to do. But I personally know of no such case. Everything is handled very confidentially. You are using an encrypted email to communicate with the IAEA from the field. When you are at facilities or in countries, you seal everything up so that nobody can open your case and take things out. So everything is very secure. And when you go back to the IAEA and report on your activities, this is done in closed rooms and without access to other people. So nothing is, I can say that to my knowledge, information is not shared by IAEA inspectors.
Okay, thank you so much. Those that raised their hands and were given the permission to talk, if you still have your question unanswered, you can unmute and then ask. We still have 2-3 minutes, I think.
Yes. Maybe if the participant can raise the hand again.
Okay. There are 2 more questions.
We have another one from Colette.
Yes. Who bears the cost of the 4 measures required for the export of nuclear technology? Is it the beneficiary or the exporter?
Okay, I like this question. Of course, if you are the importer, it's your obligation to have measures in place to ensure that you meet all the requirements of the NSG guidelines, so that cost is on you. And at the same time, the exporter has to have the same measures in place to ensure that his or her exports only go for peaceful uses. So actually, it's the exporter and the importer both have to bear the measures, bear the costs of the measures.
Okay. And the other question is, what is the procedure in the case someone okay, that has already been answered.
Yes. Mhm.
The next one is, according to the NPT, what is the threshold between non-weapons and weapons enrichment?
Okay. Well, I guess you want to know what is considered as highly enriched uranium by the IAEA. The NPT is an overall agreement. It does not go into this level of detail. According to the IAEA, anything above 20% enrichment is considered as highly enriched uranium. So most of the reactor fuel is just below the 20%, because if it's above 20% and considered as highly enriched uranium, there are really rigid measures by the IAEA in place, like they would come monthly on inspections, etc., etc. So we have the 20% where the highly enriched uranium starts to be considered as HEU. And then as you progress in the enrichment process, anything that is above 90% is considered weapons grade uranium. So if we, for example, look at the case of Iran, which was enriching to 60% without any obvious civilian use, they were just one step away in the enrichment process from producing a weapons-grade uranium. So one more step in the enrichment process, and they could have had a weapons-grade uranium, and this was what was considered to be somehow a dangerous situation. Because if they decided to produce nuclear weapons, it would have been very easy for them. Which does not mean that I support the bombing of nuclear facilities. Especially since I've been there before and I know all of them, and I still know some of the people who have been working there. But that's a whole different story.
Yes. Okay. Someone asked about whether the link will be shared in the WhatsApp group, but it's been shared in the chat, so you can visit the chat section, and then you find all the links there. And then Ms. Flansha will also be sharing it through the WhatsApp group. Another question here is that, what is the connection between export control and radioactive waste management?
Okay. Is it Aisha Ali from the UAE?
Yes.
Oh, hello, Aisha. Nice to see you. Okay, so actually, we have to in terms of safeguards and IAEA, we have to IAEA safeguards. We have to distinguish between nuclear and radioactive. Nuclear is also radioactive, but radioactive is on the higher level, and then we have the nuclear material, which are just those 3 types of uranium, plutonium, and thorium, as I mentioned. Actually, nuclear export controls don't monitor the waste, but they do monitor the export of nuclear materials. So if nuclear waste is exported, it will be subject to export controls because it contains uranium, thorium, plutonium. But from the national point of view, it is important to have measures in place to handle radioactive waste at all times. So either you store it in one location in a secure location, or you build a repository or whatever. Okay, I hope I have answered this question.
I think there are no more questions.
There was a raised hand just now, but it has
Okay.
disappeared.
Let me check.
Yes, I allow the participant to talk. Maybe if
Okay.
the participant can open the mic, that'll be great.
There is a question in the chat from Mustafa Kofi. He says, can you please shed light on state-level concepts of safeguard?
That's a very good question, Mr. Mustafa Kofi. Actually, I could give a whole lecture on the state-level concept, just very briefly. In the past, many years ago, when safeguards, IAEA safeguards were established, the IAEA was looking just at facilities. They did not look at the state as a whole. So over time, and with all the experiences that the IAEA gained during safeguards implementation, the IAEA came to the conclusion that they need to look at the state as a whole, so at the nuclear fuel cycle, the nuclear program, the R&D, everything, in order to determine what types of safeguards measures are required. So this state-level concept will also depend on the type of safeguards agreement, whether an additional protocol is in place or not, whether integrated safeguards are being implemented. So a lot of things, a lot of concepts here, where the time is too short to explain. Florencia, maybe we can talk about this in one of the future lectures about
Yes.
a little bit more about what this means and etc. Because it requires more time to explain this.
Definitely. I took note of this, and then maybe we do it in the briefing session after the school outcomes, what we are having for today.
Okay.
Okay, so I think those are the questions in the Q&A session. So if you raised your hand and you are given the permission to speak, you can just unmute and ask your question. Both Dr. Goodluck and Ms. Eva are available to answer your questions before we end today's session.
If there are no further questions, I really encourage you to take all the opportunities you can get to educate yourselves. I think this is really important, especially free opportunities like this one. And also, for those of you who are from the African continent, there's WiN Africa, which maintains a very active WhatsApp group where you get information on a lot of different opportunities, like for studying or for internship or whatever. So please, there's is a lot available nowadays compared to my days. Just take advantage of whatever chances you get to educate yourselves. And thank you for your attention. It was a pleasure to speak to you all.
Okay, thank you so much. I think that is all for the Q&A. The contacts of the speakers are shared already, so you can always contact them. I would hand over to Ms. Florencia.
Thank you very much, Adjoa, Mrs. Eva, Dr. Jeremy, for this wonderful lecture. It was a fantastic, fantastic time. And I think we have a lot of things to do for the future. Man, this is not ending at this moment. But if you have any other further questions or ideas where we can implement in other online programs, we will be appreciate your feedback. We will be sharing a survey of satisfaction to all the participants after the school ends. So that will be a great opportunity if you can help us to respond to those questions, or even if you have any other thoughts, you have our emails, you have our contacts, so we will be very happy to hear from you every time. And this is about nurturing our community together. So this is the end for today. Thank you for your thoughtful participation today. The conversations we have had around safeguards and non-proliferation are not just for technical, they are deeply human. They reflect our collective desire to use nuclear science wisely, ethically, and inclusively. So let's carry out today's insights forward as we continue building a nuclear community rooted in peace, transparency, and global solidarity. And we look forward to seeing you tomorrow for another day of learning and connection. Until then, we thank you and we keep the dialogue ongoing. So I would like to hand over to Lancina if you have any additional remarks to share. Thank you.
Thank you, Florencia. No, I don't have any remark. I would like to thank the participant of the audience, to thank the speaker and our moderator. Thank you so much to take your time and to satisfy us. Newcomer for Nuclear Summer School is yours. It is ours. Thank you so much for your participation. Thank you.
So thank you very much. We wish you to have a very good rest of your day, depending where you are, and we see you by tomorrow. Thank you very much.
Bye-bye.
Bye-bye. Take care. Thank you so much. Have a very good day, evening. Bye-bye. See you tomorrow. Thank you so
Shalom.
much.
Thanks again. Bye-bye.
Thank you so much, Mr. Jeremy. Good evening there.